Okay, good morning. These are the questions on page 54 on static calculations that I asked you to look at. So let's look at number 4. First of all, we have this object of 7.5 Newton that hangs from the end of a cord. It's attached to a midpoint. That it's attached to. Then there are two degrees of the ceiling that it hangs from, or from the horizontal. Now the question asks us to calculate the tension in each half of these strings. So there's various ways to do it. I like to do my vector diagrams. This object of 7.5 Newton is stationary. So that means all the forces are in equilibrium around it. So we can do our vector diagram and from there do the calculations. So I always start with my Cartesian plane, and I know this is a rough sketch drawing, so there's my force, this 7.5 Newton. Right? So what else do we know? Well, if we look at our sketch and we just do this, we know that this angle over there is also going to be 12 degrees, struggling with this pencil a bit. So to the horizontal, this one is going to be 12 degrees. I hope you guys agree with me. This is going to be 12 degrees. So, hope I'm not making a mess of this. That's my 12 degrees. So, in essence, then, if I have a line coming through here, that's also going to be 12 degrees. So, I'm just going to say 90 over there. So my question is now, how is my other force connected in there? How would that be? Well, if I look at this, this is again 12 and 12. So if I have to redraw this, and this is my Cartesian plane, so horizontal, that would be my Cartesian plane with my horizontal level. So my horizontal level in there tells me that this one is also going to be, this is going to be 12 degrees. Since this is 90, this is going to be 78. Oh, here we go. And 78. So now we have two isosceles triangles actually in here. So you could have seen it from the sketch as well. And there's easier ways to answer this, but I like doing it the hard way. You know I do it that way. Okay, so at least now we can try and solve our question. How can we solve this question? Well, we can work with the full triangle. We've got an angle and a side, and an angle and a side, so we can use the sine rule. I'm going to use the sine rule. I'm just going to change my color here to red. So I'm going to use this angle and this side. Remember, if I can get that side, then I have this side as well. And for my other angle, so this is just to state it, this is going to be sine of 78 degrees over, well, unknown is x in there. And then I have my other angle, let's do that angle, so you can see, well, it's going to be that angle, which is 12 and 12, so that's the sine of 24 over the 7.5. So now we need to solve it, and since no one is here to calculate it for me, I need to do it by myself. So 24 sine divided by 7.5 gives me a 0.05. And if I just manipulate this, so this gives me a 0.054. This is still sine of 78. Well, we can do sine of 78, and it gives me a 0.978. Remember, sine of 90 is 1, so yeah, that's kind of close. So doing the manipulation in here, if we divide by x, we multiply by x on the other side. So we can just rearrange my whole formula and say x is equal to my 0.978 divided by 0.054. So divided by that. Remember, always use your full values, and you get to a value of 18 Newton. Oh, let's hope that one is correct. Please tell me or let me know if it isn't. Right, let's move on to my next question. This one was question number 5, dealing with a ship being towed at a constant speed by 2 tugboats. What do we know if it's constant speed? We know that the forces are in equilibrium. So just to make a little note, if we have that my boat, so that means whatever is pulling it in that direction, and my drag force in the opposite, so that's my drag force, and this is my, why did I do that now? There we go. Sorry, this is my applied force. Must be equal because my acceleration is 0, there's no resultant force. Right. So let's get back to my question. It's 2 9 kilonewton forces at an angle of 20 degrees. 20 degrees. So we're looking for my horizontal force. Remember, if something is at an angle, there's an x component and there's a y component. I'm just taking you back to the last trimester. So if there is a force at an angle, there's always an x component, and then there is also a y component in there. Right, and we said we can calculate it because we can draw use information of trigonometry. So what can we do in this case? Well, let's just complete this thing. Think of that as a 90-degree triangle. I want the adjacent side to my angle. I have my hypotenuse. So I can say, if I want to calculate one of these x components, what can I say? I can say cos 9,000 cos of 20 is going to give me my x component of that. Right, that's written really ugly, but that is my component. Why do we say that? Just taking you a step back, what is cos? Cos of an angle 20 degrees is what? It is my adjacent side over my hypotenuse. So my hypotenuse in this case is the 9, so that's how we got to that. Sorry, I just needed to say that again, so don't lose me when I do this. If I calculate this, then I get f of x is 8,475 Newton. We need to multiply it by 2 to get to your applied forces. So your F applied is going to be 2 times the 8,457 Newton. That gives me a total of 69.14.5 Newton. I'm not using any significant figures here, I'm giving you the full value so you can also see what's happening in there. Okay, so if we move on, this was an A question in there. This was for A. B asked, what is the drag force? What is the drag force? Well, what should the drag force be? The drag force should be exactly the same, but in the opposite direction. Drag force should be 16,914.5 Newton, but in the hope that's clear. Let's move on to the next question. Now, in this question, what do we have? This one, Xavier, you asked about this one. We have a pivot right in the middle of this ruler. They say it's a meter ruler, so 1,000 millimeters. So the scale is given in millimeters up top. At 810 millimeters, there is a force of 5 newtons, so there's a weight, and then there's also an unknown weight that is hanging there. Now, how do we deal with it to calculate this? This is basic principle of moments that you also did last year. How do I need you to answer this? I need you for the A1 to calculate the unknown weight. I need you to state the theory. What is the theory? Theory is the sum of my clockwise moment is equal to my sum of my anti-clockwise. How do we calculate moment? Well, moment is force times perpendicular distance, and force times perpendicular distance. What takes my force clockwise? Well, it's going to be the 5 newtons. What's the distance from the pivot? Well, it's 310 millimeters. Or if we want to work in meters, which we prefer, is going to be 0.31 meters. Same for this unknown distance. That distance over there is 0.25 meters. Right, now let's fill in. Clockwise again is my 5 Newton, and it's the 0.31 meters. For my anti-clockwise, well, it's my unknown weight, and the distance 0.25 meters. If I do my calculations, what do I get? I get to 6.2 newtons. So W is 6.2 newtons. Right. Interesting question now. It asked, what is the force? Because there must be a force. What is the force experienced there? Remember, my beam is in equilibrium. What does that mean? That means two rules. My clockwise and anti-clockwise moment must be the same. That's why we did this. But for B, test the second one. It tests that the forces around my beam must be balanced. That means the forces up must equal forces down. What's my force up? Well, that's the one that I want to calculate. Let's call it X for now. What's my forces down? Well, we have that. It's the 5 Newton plus the 6.2 Newton. So, looking at that, it is 11.2 Newton up. So that is the force that the pit. That's a nice edge. There's a support force on the pit. So that's my support force. So always the two rules: clockwise, anti-clockwise moments balanced, forces up, forces down, balanced. Right. Let's look at our last question that we have, and this is about a diving board that has a length of 4 meters. And what do they say about this diving board? They say that the weight of the board is 250 Newton, and it is working in the middle. So it's a uniform beam, so in the middle that means 1 meter from the edge and literally 2 meters from the pivot. So that's 1 meter, and this is 1 meter. The total overhang of this diving board is the 650 Newton, because there's actually a little person standing there. There's a diver. He wants to dive, or she wants to dive. Now, what does the question ask? Let's look at it. A says the force on the bolt. So the force over here. So what force is required by the bolt, hanging it down, because it needs to be bolted down. Remember, it can pivot. Where's the pivot point? The pivot point is there. There's the pivot point. So let's see if we can do this question. Again, same principle. Sum of my clockwise mode equals sum of my anti-clockwise. Okay, so what is that? Well, in this case, my clockwise has two forces, so it's force times perpendicular distance plus force times perpendicular distance. Anti-clockwise is just my bolt, so there's a force and there's a perpendicular distance. So now the important thing is just to make sure you have the right force and the right distance. Clockwise, let's start with the furthest one. Is a 650 Newton. My distance is 3 meters that I have. The next one is my weight, is the 251, and what's the distance from the pivot? 1 meter. There we go. And now the unknown force that I want to calculate, and again, that is 1 meter from the pivot. There's my 1 meter. Can I calculate it? Yes, of course I can calculate it. What does it calculate to? It calculates to a 2,200 Newton. And now we have the force on those points. So look at my picture. There's a force on the bolts. There's the weight, and there is the weight of this person. So now again, in the second question, the B part of the question, it asks, what is the force? The force on the edge of the swimming pool, because that swimming pool is applying a force but in the opposite direction. Remember, this diving board is in equilibrium, so it needs to be balanced. So again, my forces is equal to forces down. So it must be equal to that. We can state it in a different way. We can say the sum of the forces must be equal to 0. And the sum of the forces is equal to 0. The net force on the plank is 0, because direction matters, right? Direction matters. So let's do this. I want to calculate this, and let's call it x again. We can say force from pivot, force from swimming pool edge. If you want to do some writing in there, what's the forces working down? Well, let's start at the 6. What does that calculate? That calculates to an even 3,100 newton. And it's not me. In my direction. Okay, so that's it for this section. Hope you enjoyed it. Let me know if you have any questions or if I made mistakes. Remember, I make mistakes. Do comment on it. Thank you. Enjoy.